Okay, in this video I'm going to do this problem, and this is a problem that's talking about set theory, and it's got a whole bunch of sets that we want to write out the elements of. Okay, it says write out the elements of the following sets described using set builder notation. So this is sort of a set builder notation problem, and we're making sure that you understand how to do this, okay? And we're going to have to apply the logic here. And it has a note at the beginning. It says that there's a couple ways of doing set builder notation where you're restricting all the elements under consideration to be elements of a certain set. So on the first statement here I have all those x's such that x is in the set A and x is equal to 1, or whatever the other condition is. Another way of saying exactly the same set, and that's why there's an equal sign here, is to go ahead and say all those x's that are in A such that the other condition, here x equals 1. And I would say that both of these are quite common ways of doing it. I would say probably that the second way is more common. But I've got some of each down below here. Okay. Let's do part A. The set A is all those x's such that, and you should know how to read this, the set of all x's such that the x is an integer in the set of integers, is an element of the integers, it is an integer, and x is less than 5. So I'm going to go ahead and say, okay, integers include all the way down to minus infinity, so A includes ... minus 3, minus 2, minus 1, 0, 1, 2, 3. They have to be less than 5. So 4 is less than 5, but 5 is not less than 5. So I can't go up to 5, and I better stop there. So there's the first one, and this is an and. It has to be both. For part B, it has to be in the set of z plus, so it has to be in the 1, 2, 3, and it has to be strictly less than 5. And so I'll go ahead and write that out. This is the set. The z plus starts at 1. So 1, 2, 3, and 4 are all strictly less than 5. 5 isn't strictly less than 5. And so here's our set. Okay. For set C, it has to be in the natural numbers, counting starting at 0. And it has to be less than or equal to 8. So I'm going to start at 0, 5, 6, 7, 8 is included because it's less than or equals here. Okay? For part D, it says it has to be an integer. It has to be a positive integer from the set 1, 2, 3, and it has to be less than or equal to 1. Well, out of the set 1, 2, 3, the only one that's less than or equal to 1 is 1. So it's the set containing a single element, the number 1. This thing stopped. Oh no, it's still recording. Good. The set E. It has to be, it's all those x's which are natural numbers, and either x is less than 9 or x is greater than 11. This is an or here now. So this is a slightly different thing. Less than 9 or greater than 11. So natural numbers start at 0, so 0 through 8 are less than 9. And then, this is a 7 here. I have to go up. 9 is not either less than 9 or greater than 11. 10 isn't, 11 isn't either, but 12 is greater than 11. And all we need to do is satisfy one of these two conditions. 13, 14, they are, and so I go ... like that. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 12, 13, 14 on up. And that's an or. The next one is an or also. And here we're looking at natural numbers either less than or equal to 8 or greater than or equal to 12. And so we're going to have natural numbers start at 0. 1, 2, 3, 4, 5, 6, 7, 8. And then starting at 12, because it's x 12, 13, 14. Hey, it's the same as the set above. Yeah, either less than 9 or less than or equal to 8 yield the same result when I'm talking about integers. Same thing is with x strictly greater than 11 or x greater than or equal to 12. They both are essentially the same condition when we're talking about integers. Let's see. Last two. G. Z has got to be an integer, and it has to both be greater than or equal to 5 and strictly less than 12. So starting with 5, because greater than or equal to 6, 7, 8, 9, 10, 11. It has to be it's strictly less than 12, so 12 doesn't get into the set. Finally, part H, it has to be an integer. And it has to be greater than or equal to 5 or less than 12. Just a second here. Integers. How about the negative ones? They're less than 12, right? Yeah. Everything, negative 3, negative 2, negative 1, 0, 1, 2, 3, they're all less than 12. And greater than or equal to 5 includes 5 on up. So the less than 12 includes everything from minus infinity up to 11. And then x greater than or equal to 5, it starts at 5 and goes up from there. In other words, these two regions on the number line, one is everything from 5 on up, and the other one is everything from minus infinity on up to 12. And all we need is an OR. So this is the entire set of integers. Okay, one of those two conditions will be true for every integer. For the very small ones, it's the less than 12 that's true. For those in between 5 and 12, they're both true. And for 12 on up, it's the x greater than or equal to 5 that's true. So all integers satisfy this, and we have Z for the answer. Okay, hope this video helps on this problem.